Let's rewrite everything. We get, what, -4 equals a times -1 minus 1 squared. And then everything else is gone, isn't it? -1 minus 1 is -2, and then square it, so you get 4. So -4 equals 4a. So a is -1. Hey, that's not bad. Okay, can we get b? You have to kill this off and this off. The only way to kill this off is if x is 1, right? But if x is 1, it kills off b. The only way to kill this one off is to make x -1. But if I let x be -1, it kills off this. So I can't get b. Do you see that?
Right.
So this is where you would start thinking long way. All right? This, yes?
If you were to get a and then c,
That's
plug in those two constants and then let x equal anything like 0, then you can get b.
That's right. Yeah. That's what I said. I'm starting to think long way. Right? I'm thinking long way because I can't get, seems like I can't get b. But let's see if we can get c. And maybe if we have enough, maybe we can do this still without the long way is what I'm getting at. Yeah. Okay. So let x be what? How can we get c? We kill these two off?
Yeah.
So let's kill off those. How do you kill those both? X is 1. If x is 1, we have 4 equals, well, this is gone. This whole thing's gone. This will be 2c. This last one, 2c, if x is 1. And that means c is 2. So we have 2 of the 3 variables, right? But we still can't get b. So what's being suggested here is why don't we just come back in here and replace a with -1, replace c with 2, and then
Let x equal 0.
just plug any value you want in for x and see what happens. 0 is a nice one. 0 is always a nice one, right? So what I'm going to do is I'm going to rewrite this equation right here, but I'm going to replace a and c with what I found, -1 and 2. Now this is going to work, okay? But keep in mind, there could be a problem that comes up where you still can't do this, all right? Where you can only get 1 of 4. And then there's just no way you're going to be able to do it other than the long way. So I just needed to show you that long way so you at least had seen it once. All right, so now I've got this. And now you want to just let x be 0 and see what happens? Let x be 0. You get, what, 0 on the left? -1 times, let's see, 0, take away 1 is -1 squared, you get 1. Plus b, which we don't know. 0 plus 1 is 1. 0 minus 1 is -1. Plus 2 times 0 plus 1 is 1. And that's an equation that just has b in it. That's a good thing. So this should be 0 equals -1 minus b plus 2. So what's b? Should get 1. Should get b as 1. So I have a, b, and c, don't I? I have a, b, and c. So let's get back to the integral now. So here's where we were. We had, if I remember correctly, 1/2 x squared, was it plus x?
Yes.
Plus the integral, and then we just broke that integral up into a over, which a was -1, over x plus 1, plus b over, and b was 1, right? So b over x minus 1 plus c. C was 2, wasn't it? 2 over x minus 1 squared dx. Do y'all agree with that? Okay. No questions? This one, easy to integrate or no? Yes. Yeah? This one? Yes. Yeah? This one? Yeah. That's the constant over a linear that's repeated, and that was one of the things we said we need to do, like know how to do. This is like 1 over u squared. So u to the negative 2 and just use your power rule. So let's see if we can spit this answer out. We have 1/2 x squared plus x. The negative is going to pop out. Natural log of absolute x plus 1. This one, you don't need to pop anything out of this one, so plus just natural log x minus 1. And then on this one, the 2 is going to come out. But the antiderivative of this, you're also going to get a negative to come out, and then it's going to be x minus 1 to the negative 1 plus c. I'll double check it. If I take the derivative of this, I better get that. So this comes out, it's positive 2. This to the negative 2, which is that. So that's it. That's your antiderivative. It's all right? There's a couple of places where you might make mistakes. Just a couple. Let's look at D. I have 20 minutes. I may not be able to get through this whole one. Let's see how bad it is.
Is E easy?
I don't even remember. I don't know. I haven't even looked at it. Let me look at it after I write this down. X cubed plus 4x dx. There we go. I gave a test last semester, the one before, I don't remember, where I gave a problem like this. It was the last problem on the test. All the students thought it was the hardest problem. It turned out being a basic u substitution, that if you just let u be the bottom, the derivative was exactly the top. And there was nothing, no work that needed to be done. And people were, trying to rip it apart with partial fractions. And so you always want to keep that in mind that, like, look, it could be. I mean, look, this is cubic, right? What's the derivative of a cubic function? A quadratic function, and that's what's up there. So maybe if I got lucky, but I'm not going to get lucky here. But just always be thinking through the Rolodex of techniques before you get to partial fractions, right? And trig sub and all that stuff, yeah.
Were they mad or what?
What?
Was your class mad? They're like, what?
I don't know. Some people got it. Yeah. All right, here we go. We've gone through, we've discovered that probably partial fractions here. So do we need long division? No? Okay, so now what do we try and do? Factor the bottom, right? Okay, so I'm going to see if it factors. I think it does. Not much, but it does, right? Can't. You can pull an x out. If you pull a negative x, you're going to have a negative in front of the x squared also. So that's it. That's the best we're going to do. If this had been a difference of squares, then it would break up again, and we would have 3 distinct linear factors, and we would do a, b, and c over each of those factors, right? This is not a linear factor, though, right? This is not linear, and we can't break it down. It's what we call irreducible. So if you cannot reduce this, then you've factored all the way, then that's where we are. So what does the technique say for partial fractions? Well, let's take a look. So now I'm going to come to the partial fraction part. I'm going to take the expression, this ugly thing here, and I'm going to write down x and then x squared plus 4. equals. Now I have a distinct linear factor here, right? Distinct linear factor, I can just put a over x. What if that had been a over? What if this had been x squared? I would have put a over x, b over x squared, right? This is an irreducible quadratic factor. Here's what we do for irreducible quadratic factors. Instead of putting a constant up here, we put a linear expression up here, bx plus c. Now, why in the world would we want to put a linear expression on top of a quadratic that we can't reduce? Because we know how to do that, right? That's one of the things we know how to do from the things I said we should know how to do, right? What happens if we have a linear over an irreducible quadratic? You do something. We know how to do it. Okay, so we'll see when we get there. So that's going to be it. So now what we do is we come in here and we multiply both sides by the common denominator, right? So let's do that step. Left side, when we multiply the left side by the common denominator, we just get the numerator, right? 2x squared minus x plus 4 equals, and then when I place that common denominator here, and be careful on this one. That's multiplying it, right? The x's cancel here, so I'm left with an a and the x squared plus 4. And over here, x squared plus 4 cancel, and I'm left with bx plus c times x. So I need to make sure I put that in parentheses. Bx plus c times x. Got it? We together on this? Okay. You sure? All right. Do you see a problem? Like, do you see what we're going to run into? Like short method? Do you see the difficulty?
You can only solve for a, but
You can get a if x is 0, you could kill this whole thing off, couldn't you? And then you could go get a. But you're going to have no hope of ever getting b and c because you're never going to be able to kill a off. Why? Nothing squared plus 4 is ever 0 unless you're doing imaginary numbers, right? And I don't think you want to go there. So let's not. So what are we going to do? Since it's not easy to kill things off, we're just going to do the long way because it's not a whole lot to multiply out here, is it? I mean, come on. This isn't that bad. Here to here, x here, that's it. So 2x squared minus x plus 4, ax squared plus 4a over here plus bx squared plus cx. Now I put my x squareds together, I put my x's together, I put my constants together on the right side. Left side I'm not going to touch. ax squared plus bx squared. In order, cx would come next and then plus 4a. Like that. I'll go one more step before I start matching things up. I'm going to pull the x squared out of the first two and pop it to the back. And then I'm going to write down over here right. The red stuff is what I've got to match up, right? The stuff in front of x squared should equal to 2. The stuff in front of x, which is this, right? This, c, I already know what c is, don't I? And holy crap, look at this. 4a must be, I already know what a is. 1, just by looking. But I'm going to write them down, okay? I'm going to write down those equations. That wasn't so bad, was it? Okay, so a plus b must be 2. C must be -1, and 4a must be 4. This tells me a is 1. This, of course, just c is -1. And then up here to get this one, what? Replace a with 1, right? Just replace a with 1. So 1 plus b is 2, which means that b is 1. What? Did someone say something? What? We're good? All right, so now go back to the integral. We're trying to integrate our original integral, right? Now becomes a, what was a? It was 1, so 1 over x plus bx plus c. bx plus c. So b is 1. So 1x plus c, c was -1 over the irreducible quadratic like this, dx. Everyone see that? Everyone see a, bx plus c, yes? Can you integrate the first one?
Yes.
Yes. How do you want to do this? Maybe.
Separate them?
How do you mean?
Separate them?
You want to split that into two integrals?
First one we just asked about.
Okay, so let's get the first one out of there. There you go. There's your first one. How did you want to do this?
You can split it into.
You want to split it into two integrals?
Yeah.
So x over x squared plus 4, and then minus, you can do minus integral 1 over x squared plus 4. Why would you want to do that? This one is this the one you're referring to? This one is a formula for arctan, right? We have a formula for this one. This one, basic u sub. U is the bottom. What's the derivative of the bottom? 2x. You're off by 2. Scale it by a half. You're there. So this is going to work. We're going to have natural log x plus 1/2 natural log x squared plus 4, and then minus 1/2 arctan of x over 2 plus c. There we go. So I'm trusting that you could do these two on your own, all right? All right, 12:30. Well, that only took me 10 minutes. Thought that one was going to take a little longer. So should we look at that last one, or? I don't know. For me to do it? I don't know. Got to do long division first, right? And then I don't see. Look, let me show you the last one. There's something, watch this. This is one of those problems where you look at it, you're like, oh man, are you serious? You're going to do that to me? There's lots of little clever things you can do in math. Some of them are obvious, some of them aren't. You ready? Watch this. Okay, what did I do? What are these two together? What's that? negative 3x. What are these two together? 2. Is that that's the top, right? That is the top? Okay. But let me rearrange the top now. Make it 4x squared minus 4x plus 3. So I'm putting this one, and this one together. I still have plus x minus 1, don't I? All over 4x squared minus 4x plus 3 dx. Agree with this? I mean, yeah, I could do that. It's kind of tricky, but I could. What if I split this into two fractions now? All of this over this, and then all of this over this. The first one's just 1. And then plus x minus 1 over 4x squared minus 4x plus 3. By the way, that's what you would have got if you would have used long division. That's what you would have gotten. So long division would have got you to the same place right here. But I just did it this way because I saw it. Cheating. Okay, now how do we handle this? Can you handle a linear expression over a quadratic? Very important that we pay attention to what's happening here. Because in the notes from last time, I said we should be able to handle a linear over what? An irreducible quadratic. The question to you is whether or not this quadratic is reducible or not. Can you factor that denominator? Does that factor? If it does not factor, then you do what I did last class, which was completing the square. If it does factor, you need to do partial fractions. But you need to know if it factors. So does it factor? How do you check? How do you check? I'm asking you. What are you looking at? How do you know that doesn't factor? What?
Oh, it's the same one.
Oh, it's the same problem. That's cheating. That's cheating. Well, how would you do it though? The way that I do it is I look at the A and the C, multiply them, that's 12, and then you look at the number in the middle, that's negative 4, and you have to come up with two numbers that multiply to be this and add to be this. And that's not going to happen. You can try like, 6 and 2, but then you'd have to make one of them negative. And if you multiply these, you won't get negative 12. You'll add to get negative 4, but that won't work. And then you try all the different variations, so nothing's going to work, okay? None of that's going to work. The point is that if it did factor, you would have two distinct linear factors, then you do A and B, wouldn't you? But since it does not factor, you're going to use what we did last class, and that is this exact problem. Do you see that? That is this exact problem. So go back and look at your notes from last class. That's everything that you would have to do now from here on out. That's partial fractions, everyone, in a nutshell. Let's see if there were any more problems that I had. You're just going to have to do homework, okay? I've done, I think, if I remember correctly, the homework videos for this section that I did is like 3.5 hours long. It's a lot of, I mean, it took me a long time to get through the homework for this section because it's a lot. It's a lot. So did I put a homework assignment? I didn't, did I?
Are we doing just odds or evens?
You would always want to start with the odds. And then to test yourself, try and get through the evens. I don't know what I did, to tell you the truth. I don't remember. You'll see, I guess. Okay, so what I would do is, this is page 334. Just do everything. No, I'm kidding. Do everything. 7 through at least 39 odds. I'm pretty sure that's what I did on the video.
And it's 23 hours?
3.5 hours. Yeah.
That's it? Just 3 hours?
Yeah. When's our test? Hold on. When is our exam? Oh, we still have time, yeah. So we are going to pick up next class. We're going to finally talk about the numbers on the ends of these, and then what it means geometrically, and how we use them. And then we start getting to applications. But really, we're going to have our test right before spring break, right? Yeah. So we meet 3 more times. Yeah, we meet 3 more times before our next test. 3 times, yep. We meet on a Tuesday, a Thursday, and then the following Tuesday, and then that following Thursday is the test, and that's it.
Question. Where does 1/2 come from?
In the formula for this, right here,
What number is it? I can't find it.
I think it's 17.
It's 1 over A.
See, U is the variable.
Oh, well,
A
because
squared.
4 is 2.
Can I ask you a question?
Yeah, let me turn off the camera.
It's number 17.
Excuse me. Thank you.